following presentation about SEFA testing is brought to you by Creative Solutions, an international consulting group specializing in laboratory furniture and fume hoods. Let Creative Solutions help you solve your complex problems. Hello, this is Chip Albright, President of Creative Solutions. For over 30 years, I've been active in the design, manufacturing, and marketing of laboratory furniture and fume hoods. During those years, I've worked for a variety of industry leaders, including Kewanee, Jamestown, Collegedale, and ALC Collegedale. My experience extends from product development and marketing to executive coaching. As an independent consultant, I have clients in over a dozen countries. I work with organizations both large and small. Whether we're focusing on product design, engineering, lean manufacturing, or sales and marketing issues, we are proven problem solvers. Since 1992, I've been very active in SEFA, serving in many capacities, including chair in 1999 and 2000. In those 20-plus years, I spent 8 years on the SEFA Board of Directors and have witnessed the growth of this organization from a small U.S. association to a global powerhouse. Much of the early effort at SEFA was focused on developing recommended practices which have become the international standard for laboratory-grade products. I participated on the original SEFA 8 committee in the late 1990s, as well as many others since then. Currently, I am the co-chair of SEFA 10, Adaptable Furniture Systems. The recommended practices define laboratory-grade products and are now a basis for SEFA membership. Companies are now required to have at least one product successfully tested under SEFA standards to be a member and to be considered certified SEFA compliant. At Creative Solutions, one of our many activities involves SEFA testing. Over the years, I've tested many products. Many passed, but quite a few failed. These tests are challenging and intended to demonstrate that your organization can design, engineer, and manufacture laboratory-grade products. So let's consider what is required to become certified SEFA compliant. The process starts with having your products tested by one of the SEFA-approved test labs. The first requirement is that you test the specified test units. This is mandatory. It doesn't matter whether you regularly manufacture such a unit or not. Standardized test units ensure that consistent standards are maintained and that SEFA certification is meaningful. Your engineering and manufacturing capabilities are being evaluated more so than the actual units. Creative Solutions has exceptional expertise in the SEFA testing process and can work with your company to get your products certified. This lengthy video shows all the testing and should help you better understand what is required. So let's look at the testing process.
This video will focus on SEFA 8M. SEFA 8 has standards for various materials. While each is slightly unique, they are all very similar. Unless you perform all the tests and have compliant results, you will not be considered SEFA compliant. SEFA 8M has to test and pass 20 separate tests to be considered compliant. Let's start by looking at the required base cabinet test unit. The base cabinet shall be a combination of cupboard and drawer per figure 1. The base cabinet shall have nominal dimensions plus or minus 1 inch of 48 inches wide, 35 inches high, and 22 inches deep. The drawer shall be above the cupboard, full width, and approximately 1/4 the height of the cabinet's face opening. The inside depth of the drawer shall be no less than 18 inches. The drawer in the full open position shall expose no less than 2/3 of the drawer interior. Cupboard drawers shall be a double door design and provide unobstructed entry into the cabinet interior with the doors open. The unit shall contain one adjustable shelf. The cabinet back shall be the removable type per manufacturer's standard design as used for access to the plumbing or chase area, with the removable panel removed. The cabinet shall be freestanding, squared, and level sitting 1 inch off the floor on all 4 leveling screws. A top of 1 inch thick 3750 PCF medium density fiberboard shall be freely positioned on the cabinet without glue or fasteners of any kind. The top dimensions will be such that it will overhang the cabinet perimeter by 1 inch. Its weight shall be included in the test as live load. Before conducting the test, a visual examination shall be conducted to verify that the unit configuration and setup conditions are appropriate. Operate doors and drawers. Doors should be free-moving and latched properly. Inspect the unit for dimensions and note the fit of doors and drawers to the cabinet body. Open and close the drawer. The drawer should be free-moving and function as specified by the manufacturer. Discontinue evaluation if unit is not in compliance or if malfunction is noted. We will look at each test being performed and the degree of difficulty in passing each test. On a scale of 1 to 10, we will consider 1 the easiest to pass and 10 the most difficult to pass. 4.2, the cabinet load test has a degree of difficulty of 5. This test is challenging the adjustable levelers and the top structure of the cabinet. The cabinet load test will challenge the structural integrity and load-bearing capability of the cabinet's construction. This test will demonstrate the ability of the cabinet to support heavy applied loads. This is not intended to test the functional characteristics of the cabinet under heavy loads. Verify that the cabinet is level and supported only by the levelers. Load the cabinet top by using 2,000 pounds of solid steel bars stacked 5 high with spaces. After 10 minutes, unload the cabinet. To pass, the cabinet will have no signs of permanent failure. After the load is removed, inspect the levelers. Any deformation shall not interfere with the function of the leveling system. 4.3 is testing a concentrated load and has a degree of difficulty of 8. The purpose of this test is to challenge the functional characteristics of the cabinet when subjected to a concentrated load on the center of the cabinet top. This test is more challenging than the first. While the cabinet is loaded, both the drawer and doors have to function normally. Using solid weights or 10-pound sandbags, apply a total of 200 pounds to the top of the cabinet along the cabinet center line. Operate doors and drawers. 4.4 is the cabinet torsion test with a degree of difficulty of 6. This test will evaluate the structural integrity of the cabinet construction when subjected to a torsional load. This tests the joinery, mechanical and welded joints. In the case of a metal cabinet, it is the welding of the components. Bolt-together construction is really challenged by this test. Fully welded units do best. Spot welding is preferred, but MIG and TIG also work. The cabinet shall be tested in its normal upright position, raised not less than 4 inches off the floor, and supported on rear and one front corner. The area of support under the cabinet shall be located not more than 6 inches in from each supported corner. Secure the cabinet diagonally from the unsupported corner with 7 solid steel bars, which is on the top of the cabinet to prevent overturning. Apply 4 solid steel bars to the unsupported corner for a period of 24 hours. Remove weight and place cabinet on the floor in its normal upright position. Observe cabinet joinery. Level the cabinet and measure the face and back of the cabinet across the diagonal corners. To pass, operation shall be normal under condition of test load. There shall be no signs of permanent deformation to front rail, cabinet joinery, doors, or drawers. When returned to normal position, the operation of the cabinet shall be normal, and there will be no permanent damage. The difference between the two measurements taken from measuring the diagonal corners shall not be more than 1/8 inch. 5.1, the door hinge test, has a degree of difficulty of 8. This test will demonstrate the durability of the door attachment, and its hardware by applying a load of 200 pounds. This will test the entire door unit and its attachment to the case. Most use a 5-knuckle institutional style hinge. It usually takes a stainless steel hinge to pass both this and the cycle test. This is not only testing the hinge itself, but the attachment to the door and to the case. Assuming the door is of a double wall construction and reasonably stiff, the greatest challenge is the hinge itself and then the attachment to the case. An inset style is easier to pass than the overlay style. The reason is that the overlay hinge has to have an offset to cross the face of the case. This introduces flex and reduces the strength of the hinge. Only about 50% of overlay hinges pass. There are many different types and grades of SS, so just being SS will not ensure passing. Sheet metal screws are not the preferred attachment method. Remove the shelf for this test. With unit and top set, add sufficient weight to the top in order to prevent overturning. With the cabinet door open 90 degrees, hang a sling made up of two 100-pound weights over the top of the door at a point 12 inches out from the hinge center line. Slowly move the door through 2 full cycles of the hinge at a 160-degree arc. Remove weight and swing door through its full intended range of motion and close door. Operation of the door after test shall show no significant permanent damage that will cause binding of the door or hinges that will adversely affect operation of the catch. 5.2 is the door impact test and has a degree of difficulty of 5. This test will demonstrate the resistance of a 240 inch-pound impact to the door face. Generally, this is not an overly difficult test. The common construction of a door is double wall, usually 18 GA, with some type of sound deadening insulation. This type of construction gives a supported surface that is capable of the impact. With unit and top set, add sufficient weight to the top in order to prevent overturning. A 20-pound sandbag shall be suspended and dropped to provide an impact of 240 inch-pounds at the center of the closed door. After the test, the door and catch shall operate normally and show no signs of permanent damage. A dent or depression is an indication of permanent damage. This test is not intended to evaluate the cabinet finish. 5.3 is the door cycle test with a degree of difficulty of 6. This test will demonstrate the durability of the door hinge hardware to withstand 100,000 cycles as a reliable measure for longevity. This takes about 112 hours to run. If the metal or the hinge pin is too soft, they will wear and fail. This is where an SS hinge helps. The type and grade of stainless is also important. Common metal thickness is 1.5 millimeters. These hinges are custom made and the exact specifications are important. Usually the hinge is a 5-knuckle with a minimum height of 2.5 inches. This test shall be in conformance to the ANSI test procedure A156.9 grade 1 requirements for cycle testing of doors. A cycling mechanism shall swing the door 90 degrees. The door shall operate for 100,000 cycles with a speed not greater than 15 cycles per minute. To pass after the 100,000 cycles, the door shall operate freely without binding. In section 6 we test the drawers. The drawer tests are very challenging, testing the construction of the drawer, the slide, the mounting to the case, and the squareness and inside dimensions of the case. A 48-inch wide drawer has a lot of flex and when loaded wants to sag in the center, pulling the sides of the drawer inward. This often causes the slides to twist. The way to pass is to make a drawer with minimum flex left to right and a slide that doesn't sag too much when fully extended. It is important to note that the slide manufacturer's rating of the slide is based on an 18 or 24-inch drawer. The 48-inch drawer we use reduces the rating substantially. A slide rate of 100 pounds will not support a 100-pound load in a 48-inch wide cabinet. 6.1 is the drawer static test with a degree of difficulty of 7. This test will demonstrate the ability to support a point load given to the front of the drawer and will challenge the drawer suspension system and the attachment of the drawer head to the drawer. This test will demonstrate the ability to support a point load given to the front of the drawer and will challenge the drawer suspension system and the attachment of the drawer head to the drawer. This is mostly testing the drawer slide and its attachment to the case. Many slides will bend during this test, which is a failure. In the US, it is typical to use a slide rated 150 pounds by the manufacturer. A slide that will pass in one manufacturer's cabinet may fail in another manufacturer's cabinet due to differences in construction. With unit and top set, add sufficient weight to the top in order to prevent overturning. Open the drawer to 13 inches of travel and hang 150 pounds from the drawer head at the center line of the drawer for 5 minutes. Remove the weight and operate the drawer through the full cycle. To pass, there shall be no interference with the normal operation of the drawer, and the drawer head should remain tightly fastened to the drawer. 6.2 is the drawer and door pull test with a degree of difficulty of 4. This test will evaluate the strength of the pull and pull hardware as attached to the cabinet. If the connection is not through both inner and outer panels, then a reinforcement plate will be needed on the inside. With a good quality pull and proper attachment, this is a relatively easy test to pass. Pulls are to be installed in accordance with the manufacturer's practice using specified attaching hardware and method. You block the door and drawer closed. Using a force gauge attached with a 1-inch wide bracket, apply a force of 50 pounds for 15 seconds perpendicular to each pull. Then revise setup to apply force downward. To pass, the poles shall resist the force without breakage. After completion of test and removal of weight, there shall be no significant permanent deformation. 6.3 is the drawer impact test with a degree of difficulty of 5. This test demonstrates the resistance to impact of the drawer bottom. In metal, this is usually an easy test since the drawer bottom and sides are generally one piece. This is only a challenge when the bottom is a separate part. Remove drawer, then support each corner with 2" by 2" by 1" supports. Drop a 10-pound sand or shop bag from a height of 24 inches into the bottom of the drawer at the center. Remove the bag. To pass, there can be no damage to the bottom. 6.4 is the drawer internal rolling impact test with a degree of difficulty of 3. This test will evaluate the strength of the drawer head, bottom, and back as a result of opening and closing the drawer with a rolling load. In a metal cabinet, this is normally an easy test. In metal construction, a metal drawer is usually one piece with welded seams. Position the drawer on a table at a 45-degree angle, place a 2-inch diameter by 12-inch long steel rod 13 inches from the target impact area such that the rod will roll freely to impact the back of the drawer. Subject the back to 3 impacts and reverse the drawer to subject the front to 3 additional impacts. To pass, the drawer shall show no permanent damage. All joinery shall be intact and the drawer, when replaced in the unit, shall operate normally. Minor scratches and dents are acceptable. 6.5 is the drawer cycle test with a degree of difficulty of 10. This is one of the most difficult to pass. More failures occur on this test than on any other test with the exception of paint. This test is intended to replicate years of operation of a drawer under full load. This is the test where most units fail. Many fail before reaching 10,000 cycles. The test takes 84 hours. Often it only runs during the day, so when it fails it can be stopped and the nature of the failure can be observed. There are 2 versions of the test. You only have to pass one of them, and very few products will pass the 150-pound test. To pass, you must have a drawer that is stiff enough to minimize sagging in the middle. Attachment of the slide to the drawer in the case must support the slide and minimize the twisting of the slide. The slide itself is critical. You want a design that minimizes sagging when the drawer is at full extension. Also, the internal dimensions and squareness of the cabinet are critical. SEFA cabinets are much more precise than standard casework. It is often referred to as tight tolerance because parts are usually 0.5 millimeters and +0 or -1 degree tolerance. Attach a bracket to the center of the drawer front by bolting it through the drawer front and body. Then, attach a cycling mechanism to the bracket using a free-floating poly block and pin. A laboratory load of 100 pounds, a static of 100 pounds, shall be uniformly distributed in the drawer. Measure force required to activate the drawer. Operate from a closed position to within 1/4 inch of full extension for 50,000 cycles at a rate not to exceed 10 cycles per minute. Or you can test for a heavy-duty laboratory load of 150 pounds. The static of 150 pounds shall be uniformly distributed in the drawer. Measure force required to activate the drawer. Operate from a closed position to within 1/4 inch or full extension for 50,000 cycles at a rate not to exceed 10 cycles per minute. To pass, the drawer shall operate freely without evidence of dragging, rubbing, or binding. The force required to open and close the loaded drawer shall not be greater than 8 pounds to activate hardware. Test 7.2 is the shelf load test with a degree of difficulty of 8. The test unit for shelving is the wall cabinet. On a 48-inch wide shelf, it usually requires a number of bends on the edges to provide stiffness. Most companies opt for 1 or 2 hat channels running the full length to provide extra support in the center. This test will demonstrate the ability of a shelf and its mounting hardware to support normal laboratory loads. Mount a shelf in the manner in which it is designed. Measure the distance from the underside of the shelf to a reference point perpendicular to the front center of the shelf. Use shot or sandbags weighing 10 pounds each. Load the shelf uniformly to 40 pounds per square foot of shelf area to a maximum of 200 pounds. Measure the deflection on the shelf by measuring the distance to the reference point and calculating the difference between the 2 measurements. Record data and remove load from the shelf. The allowable maximum deflection of the shelf is 1/180th of the span and not in excess of 1/4 inch. Given that laboratory furniture is intended to be used in laboratories, most of which use chemicals, the products used should have good chemical resistance characteristics. 8.1 is a chemical spot test with a degree of difficulty of 9. The outcome of these tests is largely determined by 3 factors: the pretreatment of the product, the selection of the coating, usually powder, and the curing of the finish. The purpose of the chemical spot test is to evaluate the resistance a finish has to chemical spills. Obtain one sample panel measuring 14 inches by 24 inches. Place panel on a flat surface, clean with soap and water, and blot dry. Condition the panel for 48 hours at 73 degrees plus or minus 3 degrees Fahrenheit and 50 plus or minus 5% relative humidity. Take the panel and with a permanent marker draw a grid on the panel that is 7 rows and 7 columns. Then number each cell. Test the panel for chemical resistance using 49 different chemical reagents by one of the following methods. Method A. Test volatile chemicals by placing a cotton ball saturated with reagent in the mouth of a 1-ounce bottle and inverting the bottle on the surface of the panel. Method B. Test non-volatile chemicals by placing 5 drops of the reagent on the surface of the panel and covering it with a 24mm watch glass, convex side down. For both of the above methods, leave the reagents on the panel for a period of 1 hour. Wash off the panel with water, clean with detergent and naphtha, and rinse with deionized water. Dry with a towel and evaluate after 24 hours at 73 degrees plus or minus 3 degrees Fahrenheit and 50 plus or minus 5% relative humidity, or the currently accepted guidelines set by ASTM using the following rating system. Level 0, no detectable change. Level 1, slight change in color or gloss. Level 2, slight surface etching or severe staining. Level 3, pitting, cratering, swelling, or erosion of coating, obvious and significant deterioration. The chemical percentages are by volume, not weight. Results will vary from manufacturer to manufacturer due to differences in finish formulations. Laboratory-grade finishes shall result in no more than 4 Level 3 conditions. Suitability for a given application is dependent upon the chemicals used in a given laboratory. After the test is completed, each cell shall be evaluated and rated either 0, 1, 2, or 3. It is common for a list at the bottom showing the total number of each rating. Photographic proof is required. There should be a photograph of the chemicals on the panel and a photograph of the panel after evaluation showing the numbers in each cell. And finally, a close-up of each number 2 and number 3. It is customary to also record the gloss level and the thickness of the finish. 8.2 is the hot water test with a degree of difficulty of 2. The purpose of this test is to ensure the surface is resistant to hot water. Hot water is not an issue for powder paint. This is more of a challenge for wood finishes. Hot water, 190 degrees Fahrenheit to 205 degrees Fahrenheit, or 88 degrees Celsius to 96 degrees Celsius, shall be allowed to trickle with a steady stream and at a rate of not less than 6 ounces per minute on the finished surface, which shall be set at an angle of 45 degrees for a period of 5 minutes. After cooling and wiping dry, the finish shall show no visible effect from the hot water. 8.3 is the finish impact test with a degree of difficulty of 6. The purpose of this test is to evaluate the ductility of the coating. This test is generally not difficult if proper curing and cross-linking has occurred and the sample was properly pre-treated. With an 18-gauge CRS sample measuring approximately 14 inches by 24 inches, the panel shall have between 2 and 4 mils of the manufacturer's standard paint finish applied. Position the panel on a smooth concrete floor. A 1-pound ball, 2 inches in diameter, shall be dropped from a distance of 12 inches onto a flat horizontal surface. To pass, there shall be no visual evidence to the naked eye of cracks or checks in the finish due to impact. 8.4 is the paint adhesion test with a degree of difficulty of 7. The paint adhesion test is used to determine the bond of the coating to steel. This test is evaluating the pretreatment of the panel and the cross-linking between the paint and the bonderizer. The best results come from a part that has been pre-treated in a multi-stage system using a nanotechnology bonderizer. While pre-treated materials like EG will work, they do not test as well. The challenge is getting good results when a pre-treatment process is not used. Getting the part clean and repairing any areas damaged by welding and grinding is a challenge. Using one of the test panels, perform the following test. With a razor blade, cut 2 sets of 6 parallel lines 2 millimeters apart to intersect at right angles, thus forming a grid of 25 squares. The cuts shall be made just deep enough to go through the coating, but not into the substrate. Brush the grid area lightly with a soft brush and then place a piece of tape over the grid. Rub the tape firmly with the eraser of a pencil to ensure good contact. Remove the tape by rapidly pulling it back upon itself as close to an angle of 180 degrees as possible. To pass, a 4B rating or better, 95% or more of the grid area shall show finish intact. 8.5 is the paint hardness test with a degree of difficulty of 6. The paint hardness test is used to determine the resistance of the coatings to scratches. As a general rule, the higher the gloss level, the harder the paint. In laboratory casework, most customers want a gloss level of about 70. This test is based on ASTM D3363-0, standard test method for film hardness by pencil test 1. Using one of the sample panels for this test, clip a corner of the sample at 45 degrees, exposing a raw metal edge. Place the sample on a raw metal base plate so that the exposed metal edge of the sample makes contact with the turned up side of the base plate. Remove approximately 6 mm of wood from a 4H pencil, being careful to leave an undisturbed smooth cylinder of lead. Holding the pencil at an angle of 90 degrees to an abrasive paper, rub the lead against the paper, maintaining an exact angle of 90 degrees until a flat, smooth, and circular cross-section is obtained. On the other end of the pencil, remove approximately 13 mm of wood from one half of the pencil. Install the pencil into a Sheen Model 720N pencil scratch hardness tester. Connect a continuity meter to the base plate and to the top of the pencil, being sure to make good contact with the exposed portion of the lead. Following the manufacturer's instructions, place the tester on a surface of the test sample and push it forward approximately 13 mm. Rotate the pencil 90 degrees in the holder and repeat the test to one side of the first test. Repeat this 2 more times for a total of 4 tests, each with a different quadrant of the pencil lead. To pass, the paint shall withstand an abrasion of a 4H pencil without penetrating through to the substrate and completing a continuous circuit. Now we will look at the wall-mounted cabinet. The test unit is a double-door unit with a minimum of 1 adjustable shelf. The unit shall be 48 inches plus or minus 1 inch wide, 30 inches plus or minus 1 inch high, and 12 inches plus or minus 1 inch deep. This wall cabinet shall be manufactured to the manufacturer's standard construction and practices. The unit and shelves shall be mounted in a manner recommended by the manufacturer. 9.2 is the wall cabinet load test with a degree of difficulty of 7. The wall-mounted load test will demonstrate the strength of the back of the wall cabinet, as well as the joinery of the cabinet and function of doors when the unit is subjected to loads normally expected for laboratory furniture. Depending on construction methods, this can be a difficult test. Most US-style metal wall cabinets have the back and the sides made from a single piece of steel. Then a top and bottom are welded in. The sides have an inward flange that traps the top and the bottom. This helps support the loads. Only about 50% of the designs pass the first time. The inset style construction is stronger because of the extra bends needed to form the rabbet provide extra strength. Using sand or shot bags weighing 10 pounds each, load cabinet bottom, each shelf, and top uniformly with 40 pounds per square foot to a maximum of 200 pounds each. Maximum load to any cabinet shall not exceed 600 pounds. A maximum of 200 pounds loaded to each bottom, a minimum of 1 shelf loaded per section 7, and the top, regardless of the number of shelves. With weights in place, after a period of 24 hours, operate doors through full travel to verify normal operation of doors. Remove weights and operate doors to verify normal operation. Verify that there is no significant permanent deflection of the cabinet top, cabinet back, cabinet bottom, or shelves. After weights are removed, the cabinet shall show no permanent damage to the cabinet, cabinet bottom, or shelves. The final tests are on a standard 4-legged table. The table for evaluation shall be a standing height, 4-legged, freestanding table. The table shall be nominally plus or minus 1 inch, 60 inches long, 23 inches deep, and 35 inches high. Leg and apron size and construction shall be to a manufacturer's specification. A top of 1 inch thick, 37 to 50 PCF medium density fiberboard shall be freely positioned on the table without glue or fasteners of any kind. The top dimensions will be such that it will overhang the cabinet perimeter by 1 inch. Its weight shall be included in the test as a live load. Tables can be represented by a very large range of styles and designs. 10.2 is the table static load with a degree of difficulty of 7. This test will challenge the table components to loads that are used in the laboratory. Load the tabletop by using solid steel bars, each weighing 50 pounds, stacked evenly and spaced. This evenly distributed load should be 600 pounds for freestanding tables. Include the weight of the working surface as live load. To pass, there will be no structural breakage from application of the load. With the full load, the apron rail shall not deflect more than 1/360th of the span of the table and not to exceed 1/8 inch. In the case of a table with a drawer, the deflection of the rail shall not interfere with the function of the drawer. After the load is removed, inspect the table for structural damage. 10.3 is the table racking with a degree of difficulty of 8. This test will demonstrate the structural integrity of the table construction when subjected to a racking load. Most racking failures occur upon dragging an unloaded table across a floor. The ability of a table to resist a racking load will indicate less damage to the structure. The following tests were based on and adapted from ANSI BIFMA X5.5 1989 American National Standard for Office Furnishings Desk Products Tests. Adjustments have been made to better accommodate the specific applications of tables used in laboratories. What this is testing is mainly the connection of the legs to the frame. The table shall have a common 2x4 wood rail clamped on the center line of the top parallel to the ends of the table. The table shall then be positioned at 45 degrees with one pair of legs on the floor and the other raised and supported. The table shall then have 250 pounds of weight placed on its top and held in place by the 2x4 wood rail. The unit shall remain in this position for 72 hours. When returned to normal position, the operation of the table shall be normal and there will be no signs of permanent damage. This concludes all 20 tests. The results now have to be reported on the SEFA test report template. For a report to be accepted, there has to be clear photographic evidence that each test was performed correctly. Failure to perform a single test or to obtain a passing result is non-compliance for the entire product. There are hundreds of companies in our industry. Most are not producing true laboratory-grade product. By demonstrating that you have SEFA-compliant product, you have joined an elite group capable of providing the market with laboratory-grade product that is not only safe, but will perform well in the laboratory environment.
Hopefully this video has been helpful. First-time testers often find some of these tests very challenging, but a good design that is well engineered will pass. Creative Solutions has learned through trial and error what it takes to engineer and build a laboratory-grade product, and we can share that expertise with you. SEFA compliance demonstrates to your customers that your organization has the ability to produce a SEFA-compliant product when required. If you need assistance with SEFA testing issues, Creative Solutions is uniquely qualified to guide you to success. We can also assist with engineering and product design. Here is our contact information. Thank you for watching, and remember to like this video.